Hi students, in last video we learned chi-square test, but in some situation there we cannot use chi-square because of its assumptions. One of the interesting assumption for chi-square is that there should be at least 5 number of observation per cell. For example, if this is the table for our chi-square calculation, in which all cell should have at least 5 numbers, not less than 5. Okay. Then, if it is 5 or less than 5, we have to make some corrections in the chi-square formula. And that correction is known as Yates correction. Here it is the Yates correction. This is Yates correction, chi-square Yates. And the formula for chi-square Yates is there, sigma totaling F4 minus Fe absolute value minus 0.05 all square divided by Fe. Leave it. Whatever may be the formula, we can follow the step-by-step procedure to do it manually. Okay. For that purpose, go to this particular example. Here, one category, just a category, right or wrong. The observed right things are 7 and the observed wrong things are 3. And what is the expectation? In order to calculate the expected frequency, we have to sum up these 7 plus 3 and it is equal to 10, right? Then if 10 is divided into 2 equally, the expected frequency for right and wrong, it should be equal 5 and 5, isn't it? So these 5 and 5 are the expected frequency. So this is the observed frequency. In actual practice we get 7 and 3, and 3 is less than 5. So we cannot use the original chi-square formula. We have to use this particular what is called Yates correction formula. So we can start the actual problem calculation, and this is adapted from Garrett. Okay, the same problem is done here, and this is the method we have to follow. Then first step, minus F4 minus Fe. Calculate F4 minus Fe. That means equal to this 7 minus 3. So simple calculation. Then the obtained value is 7 minus 5, 2. Okay. Then the next value is 3 minus 5 is equal to minus 2. Then in the next step, we have to reduce a correction factor, and that factor is 0.05. 0.5. We have to reduce or subtract that figure from F4 minus Fe. That is, from this figure of 2, we have to reduce this figure minus 0.5. So here I add 0 equal to, from 2 we have to reduce this particular figure 0.5 here. This is the formula. Then by reducing 0.5 from 2, the value is 1.5. Okay, the obtained value is 1.5. Here another important thing is that this is a mistake, because we have to take only the absolute value. We have to take only the absolute value. So we cannot consider the negative sign here. Okay, and this is a mistake. So we have to change it into a positive value. Then only we can correct the thing. I think it's enough to correct. No, it is not the method to correct it. Okay, just leave it. What is the value? -2. Reducing the converting it into absolute value, just remove the sign, then the value is just 2. Okay, just give 2. Here also 2, here also 2, and 2 minus 0.5, 1.5, right? Then we have to make square of this value. There is a yeah, now it's clear. Then we can click here equal to, then click here and raise to 2, right? 2.25. The same can be applied here, 2.25. Then we have to divide this figure by FE. That is the last step. FE, we have to divide by FE. That is equal to 2.25 divided by what is FE here? 5. 5 is the expected value. Just click here. Okay, and this is the value now, and calculate the same for the wrong case also, wrong category also. We will get 0.45 here and 0.45 here, and just sum up these things equal to this value plus this value, which give 0.9. Here the obtained chi-square value is 0.9. Yeah, now this is the result. Chi-square is equal to 0.9. Now compare this value with table value. That's all. The all other things are same for chi-square, usual chi-square. Okay, I think it is easy for you to follow. Now you just create another problem and do it yourself. Got it? Thank you.